Now let's look at the tutorial, question 1. Okay, a hammer throw athlete, right? He's whirling a steel sphere at the end of the court. So your radius, right, is 0.8 meters, okay? And your sphere mass is 2.2 and is in this circular path, okay, vertically. Okay, so what you do is you look at this path, and part A, the maximum tension or in the court where the speed is 100 rpm. So speed is 100 rpm, you convert to omega is 10.472 radians per second. All right, so there are a few scenarios that you can think of. The first one is, of course, when it's at the very top. Okay, and then the second one is when the sphere is actually at the very bottom. Then you ask yourself, which one will there be a higher tension? Okay, if you happen to have turned a bucket of water before, you know that the chances of the water falling down, right, is actually when it is at the top position. um, Instinctively you will tell yourself that the higher tension is actually at the lower position. We can actually find out. Okay, so if your speed is 100 rpm, right, and is rotating constantly at this omega, if you look at the top position, what forces do you have? You have your tension, okay, and you also have your weight, mg. So actually you have two forces towards the center of the circle, right? So what will you do is you do your Newton's second law lah. Sum of forces equals to ma, right? So ma in this case is mr omega square. So what forces do we have? Mg plus t equals to mr omega square. This is fixed, this is fixed, omega is fixed, so this whole thing remains the same. Okay, but your tension now is actually mr omega square minus mg. Now look at the second scenario. Okay, when the sphere is at the bottom, what forces do you have? My weight is still pointing downwards, okay, and my tension is pointing upwards. So when you do sum of forces, right, equals to mr omega square, you will realize that now it is t minus mg. Okay, because the overall direction is still pointing towards the center. T minus mg is, let's just draw this r omega square, right? mr omega square, and you will find out that the tension expression is actually mr omega square plus mg. We're comparing the top position with the bottom position. This bottom position will have a higher tension. Okay, in fact, across the whole circular path, it will have the highest tension value. So what is the maximum tension? The maximum tension occurs at the bottom position. Okay, and you can find this 0.8 times 2.2 times 10.472 square plus 0.8, sorry, 2.2 times 9.81. Okay, so the answer is 214.59 Newton. Okay, which is the answer, 214.6 Newton. Okay, the minimum rotational speed, which the tension in the court disappears. Okay, if we look at this scenario again, between the top and the bottom, which position will likely, which position will it be that the tension will likely be 0? Okay, the answer is at the top, because there will at the top, the position, right, where the chances are that the tension is actually not there, but the path is the sphere is still going at the circular motion. Okay, so the minimum rotation speed, well, okay, the tension disappears will be at the top position. Okay, so if I take this equation again, okay, T equals to mr omega square minus mg. When the tension disappears, 0. It means that my mr omega square is now equals to mg. Okay, cancel the mass on both sides. My omega is g over r square root. Okay, (3.5 radians per second). Okay, the answer is in revolutions per minute. Then it will be 3.5 times 60 over 2 pi. Okay, 33.4 rpm. Okay, the answer is 33.4 rpm. So that's it for first question.